Hey guys, it's Mr. Zimmerman, and today we're going to jump into lesson 3, and we're going to actually explore some new ideas about exponential functions, and we're going to look at the inverses. Now let's have a little fun, shall we? All right, so essentially, what are they telling us? Consider the table and graph for the basic exponential function f of x is equal to 2 to the x. Okay, it looks like it's growing. It's f of x. It's growing. It's blue. I know that it's going to continue this behavior. If I look at the other side, I know that it's going to continue to approach 0. It's never going to quite touch it. Okay, so it says fill in the key characteristics in this table below. So it says it has f of x, and then over in the red, it has f to the negative 1 of x. And what this is the inverse. Now I do want to make a notation. This right here means it's the inverse. It does not mean the reciprocal. For example, if I had 4 to the negative first, this is going to be 1 over 4 to the 1. This notation is a little different when it's next to a function rather than in our warm-up. When we did 4 to the negative 1 and 4 to the negative 2, they were talking about the inverse in a way. We define it more as reciprocal, so it's not exactly the same wording, but I just wanted to point it out. All right, so the domain. As I noticed over on the left, my scan left to right, is that it's going all the way to the left. Negative numbers do work, 0 works, and it's going to continue to grow. My range. Now this is where it's almost touching, but it's not touching. So if initially I was going to write, it goes from 0 to infinity, this would be incorrect. I would want to make sure I include 0 to infinity because the 0, it does not touch it. It's an asymptote. The next question. The asymptote is x equals 0 because it's horizontal at the y-axis. My x-intercept? Well, didn't I just say it doesn't touch the x-axis? So no, there is none. The y-intercept, I look at my graph, it's 0, 1. And this is the parent function always has a y-intercept of 0, 1 because any number to the 0 power, 2 to the 0 is 1, 4 to the 0 is 1. I could go for days. Now, intervals of increase and decrease. Well, this is increasing the whole time. Increasing. And it's increasing from negative infinity to positive infinity. Now in behavior. I have to just memorize this. When x goes to infinity and x goes to negative infinity. That means the output, I need to talk about it. This is what this end behavior means. This is standard 7.2. You will have to compare it to the right and to the left. When x is going to the right, it is going up, 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 and it is going to be to infinity. Now, as x goes to the negative infinity, it's going closer and closer to 0. Voila. Let's do the same thing for the inverse, shall we? The inverse. Well, it looks like it doesn't even cross this. I know that it might look like it's on top, but it's actually just really, really, really close to the y-axis. So, 0 to infinity. My range, this is where, it can be negative, and it goes up. And if you look at f of x and f of negative 1 to the x, you might be able to see that, literally, they are inverses. So I switch x and y. The domain of x becomes the range of the inverse. Pretty cool, but I could observe it with my own eyes on the graph, and I can make these connections as I go. I switch x for y. That's why my asymptote is now vertical at the y-axis. No y-intercept anymore because the y-axis is now an asymptote, and I switch x with y, right? So originally, for 0, 1, it was x, y. Now it's going to be switch x and y. That's going to be where the asymptote is.